Hi, this is Team 9. Last week we learned about the important earth retaining wall for the foundation work before learning about the full-scale construction process at the site. Last week we looked at the site adjacent to Mount Kumdae. So now let's find out the kind of earth retaining method that was applied to the rest of the parts, especially in the railroad adjacent area. First is on the opposite side of Mount Kumdae. In this part, the level difference is relatively low, so the soil to be supported is one level underground. Therefore, IER method was used, which does not require a separate support method, because the earth pressure is not strong. What is IER? The IER method is an abbreviation of Inclined Earth Retaining Structure. It is a method applied to earth retaining walls by fastening the front part in a simple structure, focusing on the fact that the supporting of the vine plants are resistant to shaking from side to side. The structure includes a front support that acts as a retaining wall, a back support that reduces the earth pressure acting on the retaining wall, and a fastener connecting both parts. First, install the front post and rail, and assemble the vertical pile fastener. After that, the structure of the IER is completed by installing the back support, then assembling and welding the inclined pile fastener, and finally installing and welding the spacer. As mentioned above, the IER construction method has the advantage of being very simple to construct because there is no support and it greatly shortened the construction period. Also, it was efficient because of the time shortening of constructing the retaining wall in this part. At our site, two H-beams were constructed vertically and a horizontal beam was constructed at the top. The vertical beam inside the site and the upper horizontal beam were connected to prevent the vertical beam from falling over. It is a method in which two rows of vertical beams are constructed together, and the inner and outer vertical beams are connected to the upper horizontal beam using bolts and reinforcing bars for support. The vertical beam outside the site serves as an anchor to prevent the wall from falling over, and in the soft soil. The soft soil on the bottom loses its bearing capacity and collapses due to the weight difference between the inside and outside of the retaining wall, and the soil outside the retaining wall is pushed inward to the bottom of the excavation. It also serves to prevent heaving, a swelling phenomenon. In addition, since it shows the effect of piles to prevent the activity of the land surface, it reduces the earth pressure acting on the earth retaining wall. In the case of the impermeable wall, the wall stands on its own to a certain depth without a support material because it has no damage. The risk of settlement or loss of soil particles are low. The following is the part with the railway adjacent area and access road, which is the most important part of our site. The area adjacent to the railroad and the part on the Mount Kumdae area are similar in weight of soil to be supported and strength of retaining wall required. However, if the earth anchor method used in the Mount Kumdae area is used in the area adjacent to the railroad, it may cause damage to the railroad and rather weaken the ground. Above all, it is impossible to use the 15 to 20 meter earth anchor because it invades the railway protection area. Then, we will find out how the earth retaining method and supporting method that were used in this site. First, let's look at the retaining wall construction method. In the area adjacent to the railroad, the CIP method was used as a retaining method. Why was the CIP method used in this area? This area is demarcated above the rail line. Looking at the geological elements of the construction site that we mentioned previously. Soft rock formations are formed on the left side of the site near the railroad line. The existing earth retaining wall only needs to go down 2 meters from the upper line of excavation, but we wanted to use the method of inserting more from the soft rock layer to the bottom to 1 meter to prevent the earth retaining collapse using these geological elements. As mentioned last week, the CIP method can be installed on any ground that can be drilled, so it has the advantage of being unaffected by ground conditions, and the bearing capacity is significantly great due to the increased friction between the concrete pile and the surrounding ground. This is why we use CIP method in this area. Following the earth retaining method, we will move on to the supporting method. First, let's take a look at the corner of the supporting method, the strut method. The strut method is a method of excavating while supporting the retaining wall with a horizontal strut. That is, a strut using the balance of earth pressure on both sides after the retaining wall is formed. Simply, the strut method is a method of pushing the retaining wall from the front to prevent it from falling. In addition, it is applied when the plane shape is square due to the size of the excavation being medium or smaller. It is a method that is easy to repair and reinforce after construction, so it is most suitable for supporting the retaining wall in the corner part. Next, let's move to this part, which is directly attached to the corner part where the strut method is used. This part uses the PS-well method. The official name of PS-well is the pre-stressed well method, and it is a retaining method that replaces existing struts by introducing pre-stress using pre-stressed wires and short supports for the well. In general, the retaining wall support method used during excavation work is the strut method used in the corner part. However, this method has the disadvantage of causing interference during the underground excavation work delaying and increasing the construction costs. This is caused by the narrow spacing of struts supporting the retaining wall, and can be overcome by widening the spacing of the struts, and the PS-well method is a construction method using that method. Now let's move on to the rest of the railroad adjusting area. The supporting method to be used instead of earth anchor in this part is the raker method. The raker method is a method of supporting earth pressure by installing a spread beam on a support block or pile so that one end is supported on the ground at an up and down slope. The raker method has the advantage that it can be used when there is no space for external land or when anchor construction is not possible for the adjacent site. So it can be considered as an appropriate method to use instead of the earth anchor. However, if you watch the video, the raker method is not visible. What could be the reason? It is because of the existence of a temporary ramp on the access road near Gate 1. Since this temporary ramp unintentionally serves as support, the immediate support method is not needed. In the future, we are planning to apply the raker method after removing the temporary ramp. In conclusion, we have talked about all the contents of the railroad adjacent area, which had the most considerations and even the solutions. Also, from last 2 weeks, we finished talking about earth retaining. In the future, we will look at the overall placing plan. Next week, we will look at the placing plan of the basement. Thank you for watching.